Could we communicate faster than light? Could we detect planets at Alpha Centauri? And what could we launch with Starship? All this and more in this week's Overtime Question Show. Hey everyone, well, we've reached the end of the Overtime Question Show segments, and that's because the regular question show is coming back. And that's because we're now doing the live streams on Monday nights again. And so this is the last episode of the content that we recorded right at the end of the last season. I hope you enjoy it. All right, let's get into the questions. Chris von Schweitnitz. Any past or upcoming missions that will test out the ability of two quantum entangled electrons to communicate with each other faster than the speed of light? There's no need, because there's no way for two entangled electrons to communicate faster than the speed of light. And like, obviously, we know that there's quantum entanglement, that you can have particles that can, if you entangle the particles and then one is spin up, then the other one will be spin down, but that doesn't allow you to communicate any information. The analogy that I always use is if I take a coin and two boxes and I put the coin into one box, and I give you one box randomly, and I give your friend one box. You guys both go home. And then at the time of your choosing, you open up the box and find out whether or not there's a coin in your box. And you open it up and you're like, nope, no coin. And your friend opens theirs up and goes, oh, coin. Well, you know that the other person had the opposite of what you had, but there is no information that is being transmitted between you. You can't go, open your box with your psychic powers. And so until you call them up and go, I opened my box and I got a coin. And they're like, I opened my box and I got no coin. Now you're communicating at the speed of light. And so you don't get to communicate faster than the speed of light. So no, there are no missions because it won't work. Rob Hawk, why do we focus on Proxima Centauri when the other two stars in the system could have better planets? Will we ever be able to detect those other planets? I mean, you focus on Proxima Centauri because the star is not very bright compared to any planets that are nearby. And in fact, planets have been discovered using the transit method at Proxima Centauri. And that's because, it wouldn't have been possible if the stars were a lot brighter. I guess it probably would have. But people have looked for planets around Alpha Centauri and they haven't found any. And the big part is that the stars are so bright. However, there was a really cool mission idea that's in the works and should launch pretty soon called Ptolemy. And what it's going to do is it's going to, because you've got these two stars that are orbiting around each other, you've got these two reference points. And what it's going to do is it's going to look at one star and like center it in its optics. And then it's going to look for any little wobble in the other star as the star is orbiting around. And if it detects a little wobble, then it might be able to detect the presence of a planet. And then it's going to switch targets, look at the other star in Alpha Centauri. And it's only going to be looking at Alpha Centauri. Its only job is to search for planets at Alpha Centauri. And it doesn't have to be very big. It's a CubeSat scale mission, probably going to launch next year, I think, and could give us an answer relatively quickly on whether or not there are planets at Alpha Centauri. So, the current crop of space telescopes aren't able to, we know that if there are planets at Alpha Centauri, they aren't lined up perfectly in a way that we could detect their presence with the transit method. So that leaves the radio velocity method and this mission that I mentioned, Ptolemy. I've got an interview that I did. If you search for Ptolemy, Toliman, it's an hour-long interview all about the search for planets at Alpha Centauri. But I can't expect you to have watched every single video I've ever made. I understand that. Joe Andrew, will satellites get more complicated or less with Starship? Are there enough customers to take advantage of a Starship? The launch mass of James Webb was about 7 tons. And that was sort of the most launch mass that could fit within the Ariane 5 rocket. It wasn't the size of the payload area, it was the mass that it was capable of launching. And so the major engineering hurdle to building James Webb was to make it fulfill its functions, but also to shave off all of the weight. And so every time they were looking at any part on James Webb, they have to say, could we have this be lighter? Is there a way that we can remove some of this mass? And they just had to do this process again and again and again and have to re-engineer things to get the mass down until finally they were able to make the whole thing fit within what the Ariane 5 was capable of launching. If Starship, when it gets into this place where it's actually launching payloads into space, it should be able to launch in a 9-meter fairing, just enormous amounts of mass. And what that does is it makes the job of the mission designer so much easier. So instead of you having to go and create this super lightweight version, we think about like cycling, right? You want to buy a nice bike You can go buy a bike for $50, or you can buy a carbon fiber composite bike where every part has been shaved down to the minimum weight, and now you're spending $10,000 or $20,000. And it's just like, how much time do you want to spend to make this thing lighter and better and still perform the function of letting a human being ride a bicycle? And so the same things with satellites. And so with Starship, you've got this enormous payload area and a capability of launching an enormous amount. And so maybe we do something really simple. So instead of making a really fancy, complicated space telescope, you literally just take a big mirror, like the equivalent of an observatory, and you jam it inside Starship and you send it to space. And now you've got an 8-meter telescope, bigger than James Webb, in space. And there's nothing complicated about it. It's a primary mirror. You take one of these mirrors that are built for the different world's observatories. You just put one of those on a telescope and you send it to space. And now you've got an 8-meter telescope in space. Yeah, you're going to need some power and blah, blah, blah. But so I think that there is a whole generation of mission planners who had to figure out how to shave the weight out of everything that they were building. And now suddenly they don't have to do that anymore. And I think it's going to be this entirely new learning experience. If they're able to get a launch on Starship, they're going to have a hard time coming up with ways to use up all that mass. So yeah, it's going to get pretty weird for a while. Goat Lord, can we detect radioactivity on other worlds as in a nuclear winter, and will this be considered a technosignature? So this is one of the technosignatures that has actually been proposed by astronomers. There's a list out there somewhere that I really want to get my hands on that lists all the technosignatures that have been brainstormed so far. And this is one of them, yeah, that you would detect the radioactive fallout in the atmosphere of a planet. Now, that's a thing that you would see, and then you'd be like, oh, those poor suckers just wrapped up a nuclear war. But it isn't necessarily something that we are capable of detecting. But there are certain amounts of, imagine particulates in the atmosphere. So they are proposing, astronomers are proposing ways that you could identify a planet that just went through a nuclear war. Yes, that has been considered a technosignature. It's terrifying. Astro surveys, will New Horizons visit other dwarf planets? It has fuel in the tank to visit more targets, but so far none have been selected yet. I think Vera Rubin is going to find targets that then will be considered, in the future flight cone of what New Horizons is capable of, and then they may very well try and do them. So it can do more flybys, it just doesn't have any targets yet. Rev Keith Carter, can you explain the virtual landing of the IFT-4 units? Were there computer simulators for precise spots, or was there just general areas? When Super Heavy returned, they landed in the ocean. But the question is, can you land this thing at the launch platform? Will the chopsticks be able to grab it? And I didn't hear that they were performing an extremely accurate simulation of what it was going to be like. They were just coming in. Now, we saw an additional footage from a buoy that was out in the Gulf of Mexico, and they came close to that buoy. So in other words, they knew where they were going to try to land out in the ocean, but they didn't have a simulated chopstick area out in the ocean. And then of course with Starship, because of all of the problems it was having with the reentry, it was about 6 kilometers off of its expected landing spot. So they were not precise at this point, but they have to be precise if they're going to work. I mean, they have to work every time without fail, or they destroy the launch system. That's scary. I don't know. I don't know how they're going to get around it. You can never fail. Yeah. Nom, what do you think the new heat shield is going to be like? We don't know. So actually in the video that I have to review, we talk a lot about the heat shield and what the new plans are. So right now the heat shields are attached. There's a pin, and then the heat shields are attached to that. And so they're not welded onto the outside of Starship, but one possibility is they're going to weld these things down, try and make them stronger. The other possibility is maybe some kind of ablative gel or adhesive that'll go under the heat tiles, so that will be an adhesive for the tiles, but also provide another layer of cooling. So we kind of don't know what their plan is to increase the heat resistance for Starship. I mean, the big challenge is the hinges, the things that, we saw as Starship was coming through. We saw those gases making their way into the hinge system. We saw the thing just like on fire with bits and pieces, and things were melting and just tearing away. And that has to survive, because that's how you have your control. So all eyes are going to be on how do they provide some kind of flappy control surface that is also incredibly resistant to the re-entry from space. And I don't know what that's going to look like. But, I think safely we can say they're just going to keep adding heat shielding until the thing is safe. And as they add more heat shielding, then that decreases the amount of payloads that they can launch into space. And they will finally reach some number where, like, okay, we thought we could deliver 100 tons to orbit, or 110 or 200 tons, or whatever was going to be the number. But now we're down to 75 tons or 50 tons or 25 tons or whatever. There will be a final number that incorporates all of the structural elements, all of the the hot fire staging capability, the heat shielding, that will make this thing rapidly reusable. And I think that's fine. It would be great if they could launch 100 tons at one go, but because the thing is theoretically going to be rapidly reusable, then you launch 4 of them and they dock in space and then they fly off together. So I'm not that worried about it. Taryn Pulakanti, are we any closer to discover some new physics anytime soon? Well, I mean, if we knew, then we would discover those physics. There are large problems in existing physics. There are big questions. There are places where people know things are incomplete. Like, how do you make quantum mechanics and gravity work together? What is the nature of dark matter? What is the nature of dark energy? Why is there more matter than antimatter in the universe? Did inflation happen? So there are all of these unknowns that we have, but then there are new physics that we don't even know that we don't even know. And sometimes those can be found just randomly by people who happen to be working on the right things. So, you're kind of asking, are we at the end of physics? And people have always predicted the end of physics. And I don't think we're anywhere, we're nowhere near the end of physics. And especially back to that question we had earlier on about AI. I mean, AI is coming online to be able to help search for new physics at an accelerated rate. Imagine if you fed quadrillions of particle collisions into a large language model. But it wasn't a large language model, it was a large particle model. And then you have to start looking for patterns and trends and make predictions and stuff. Who knows what kinds of physics might turn out from that. So I think, I'm way more interested in AI being used for scientific applications, like AlphaFold, like searching for new medicines, like new metamaterials, things like that, and physics and cosmology. I've got 2 interviews coming up with different teams who are looking at how they can use AI for astronomy. And so I really, it's a thing that I'm obsessed with right now, and I want to get to the bottom of it. Faisal Sahar, how does the discovery of structures like the Hercules Corona Borealis Great Wall challenge our understanding of the universe's size and the cosmological principle? I don't think that things like that, these large scale structures of the universe challenge our understanding of the universe's size. Like, at the largest scale, you have this distribution of matter that is based on the distribution of dark matter that is concentrating particles, galaxies, stars into these large scale structures. And as you get the expansion of the universe, the gravity of the universe is pulling the mass and material together. It's opening up these voids in between these large walls and structures like that. And, currently the lambda cold dark model, theory of the universe explains the large scale structures. And now astronomers have made really complicated simulations on supercomputers where they incorporate all the particles of dark matter, all the particles of gas and dust and the forces involved, and then run the simulation and get those kinds of large scale structures of the universe. And so at this point, I don't think, any of these things that have been seen, these have all been in, this current crop of simulations, the theories match the observations. That's sort of the point. And that's why the things that James Webb is finding early on in the universe, or the crisis in cosmology, the difference in the expansion rate of the universe, is so interesting because those aren't easily explainable. And so there's additional physics, ideally, will be found to explain them. Bob Hoppeldorf, any missions planning on checking out near-Earth asteroids or quasi-moons? Outer system missions take so long. Okay, so yeah, there's a new mission in the works called Neo Surveyor, and that is going to be looking for potentially hazardous near-Earth asteroids. So that's the closest that we've got. And there's a lot of ground-based stuff that's going to be looking for them. But yeah, it sucks that the solar system is so big and there's all these really interesting places, but you got to say, I'd really like to go to Neptune, but are you willing to take 10 years to do it? Oh, maybe not. That's the problem, always. Nom, how close do you think we are from finding other life forms? We don't know. We have no idea. We're taking our best crack at it, right? We've got rovers on the surface of Mars that are looking for any kind of evidence of past life on Mars. We have missions in the works to go to Europa to look for any kind of evidence of plumes at Europa, and maybe there's going to be the presence of life in those plumes. We've got SETI researchers that are looking for signals from intelligent civilizations. And then you've got things like James Webb, which could potentially detect the presence of biological signatures in the atmospheres of other planets, would tell you there's life there, although that's a really tough one, but it could also potentially detect the presence of pollution and technosignatures. So we have no idea. I mean, it all depends on whether or not we're alone in the universe. And, some of you know how I feel about that. Scott's Astrophotos. Will the Nancy Grace Roman telescope reside at the Lagrange point, and if so, which one? Yeah, so Nancy Grace Roman, launching in 2027, is going to be going to the Earth-Sun L2 Lagrange point. So that's the same place as James Webb, as Gaia, as Euclid. It's the best parking spot if you want to keep the Earth, the Sun, and the Moon all in the same spot of the sky away from you, and be able to look in the other direction. Jingard, what are your thoughts on black hole stars or quasi-stars? The first stars that had a black hole at the core, which is one explanation for black holes at galaxy cores. So I don't have opinions. I'm just a science journalist. And so quasi-stars, is it like gravistars? Like there's a bunch of alternative ideas for things that could give off the same characteristics of black holes. And one of the amazing things about the Event Horizon telescope was that it was able to measure the event horizon around two black holes, and they measured the predictions that were made by Einstein for what you would expect to see around a black hole. And so there are still alternative theories for what could be these enormous, very massive, dense regions in space, but the black holes are the one that are widely accepted by the scientific community. Church discography, what is your favorite life form? Swallows? Swallows are pretty great. Swifts and swallows, I think. So I like mammals, birds. I like birds. Favorite bird. Yeah, I'm going to go with swallow. They look like little jet fighters. They're so cool. Dave Swinson, in the search for life past or present on Mars, has landing on the polar ice cap and taking core samples been considered? The Phoenix lander went near the polar area on Mars. And in fact, it was what helped us understand the level of perchlorates that are in the Martian regolith. It was able to help measure the amount of water ice that's mixed in with the regolith on Mars near the polar areas. So no mission has actually gone to actually land on the polar ice cap, but they've gone pretty close to the ice cap. No name. Has anyone considered having Lagrange floating coronagraphs or secondary mirrors to avoid the noise from the support? So I don't know about the Lagrange point, but has anyone... I mean, that's essentially an interferometer. But are you saying like you have a telescope that is free floating compared to its secondary mirror, and then some method is keeping the secondary mirror and the primary mirror aligned with one another to avoid the noise from the support? I think, coming up with a way to maintain the position of the primary mirror and the secondary mirror to fly in perfect formation is harder than to just remove a little bit of data because of the additional, the diffraction spikes that are coming from your supports. I haven't seen anybody say, here's a great idea, let's have free floating primary mirrors and secondary mirrors. Roger M, could Venus atmosphere be terraformed, a compound combined in the atmosphere to turn it into H2O? So could Venus' atmosphere be terraformed? Sure, theoretically. You put a sunshade in front of Venus, and that blocks the sunlight coming to Venus, and then you cool it down, and then all of its atmosphere turns into snow, carbon dioxide snow, and it just falls down onto the surface, and now you've got this deep layer of snow on the surface of Venus, and it no longer has an atmosphere. And then you sprinkle some kind of material down that wants to bind with the carbon dioxide. Limestone is a thing that you'd be using here on Earth, but there's other chemicals, magnesium, I think, that will bind up and sort of turn the atmosphere into rock. And then you no longer have that thick atmosphere. So, you know, the problem is that, like, yeah, you could get the oxygen for your H2O, but you can't get the H part. That's the thing that Venus is missing, is the hydrogen. So Venus probably had a lot of hydrogen in its past, but that hydrogen is gone. Some of it is in sulfuric acid. So if you could break up the sulfuric acid, you'd be able to get some hydrogen, but it's just not enough compared to anything like what Earth has. So you really, if you want to have big liquid oceans, maybe it's trapped underneath on Venus, under the surface, or maybe you're going to have to deliver it by smashing comets after you've locked down all of that atmosphere. Vladimir Ikik, what do we know about white holes, and have we found any? So white holes are a mathematical construct that if you take a black hole and you change some of the numbers in the black hole, you turn positives into negatives, you get a theoretical white hole. But it's not like it's a real thing. It's, you know, imagine you take, you know, donuts, and you have, say, +6 donuts, and you give me the donuts, and now I have +6 donuts. Okay, fine. Now, what if I just turn the donut number negative? What does that mean? Like, does that mean now that you are born into this universe owing 6 donuts to somebody? So just because you can change things mathematically doesn't mean that these things are real, you know. And people have looked. So, I mean, in theory, like, while black holes will be these places of infinite density where material is falling into them, white holes are places where material is coming out of them. And maybe black holes and white holes are connected, and maybe there's a way for us to detect white holes by looking for places where material is being blasted out into the universe. No one's ever seen it. And I think it's pretty, I mean, I think you pretty safely say that they're probably just purely theoretical, mathematical devices. Francis Tony, which Starship milestone is the hardest? Storing propellant in space, refilling in space, re-entry, quick reuse, chopstick landing, business model, bankruptcy, landing on the moon, or other. Now that Starship has returned from space, and the Super Heavy has, and both Starship and Super Heavy have soft landed in the ocean, roughly where they were intended. And we can see what was the hardest part. The hardest part was the heat, surviving re-entry, getting back through the Earth's atmosphere. So right now, that is the big challenge. And who knows how many iterations, how many test launches are going to have to go through to the point that it returns back to Earth and isn't going to require essentially being thrown out. God, I don't know which of those. So the chopstick landing, you've got to land with precision at the launch platform. Both Super Heavy and Starship, one after the other, have to be able to land with precision. And if you get one mistake, then it tears apart your landing system. And, you know, we've seen mistakes even with Falcon 9s that are well proven. There's hundreds of launches that have happened. Every now and then a Falcon 9 doesn't land exactly where it's supposed to, goes into the ocean or falls over on the drone ship or whatever. And yet if that happened with Super Heavy or Starship on the chopsticks, then it will cause significant damage to the launch system. So, I mean, are you ever going to reach a point where these things are landing with 100% accuracy? I can't imagine that you will. And so are you just going to be rebuilding launch platforms as a cost of doing business? How many are you going to rebuild? I don't know. Do you build a launch platform that can handle the destruction of a Super Heavy as it hits your landing system too hard? Maybe you could build one like out of a mountain or something. I don't know. Maybe you could overbuild them at a certain point. Storing propellant in space, I think that's a solvable problem. Refilling in space, I think that's a survivable problem. Re-entry, that's just like how much mass are you willing to spend on hardening your spaceship. So landing sounds like a big one, and then quick reuse is a completely separate milestone. There's eventual reuse, and then there's quick reuse. And I think there's going to be a large gap in years where we go from eventual reuse, where Starship returns and engineers pore over each part and component, and they swap out bad heat tiles and they replace the landing fins. Like I can imagine them replacing the landing fins with every launch until they've really solved this. And another one that's kind of crazy is, you say landing on the moon, that's potentially challenging, but returning from the moon is actually pretty scary. And this is the conversation that I had with Scott and Marcus. When you come back from the moon, you're going 40% faster. It's a much harder reentry than just Earth orbit. So there's you listed a great list. I could probably add another 10 things, but I think, because Starlink is making money and is set to make more money, and Starship, they say Starship is to send humans to Mars. That's not its purpose. Starship's purpose is to launch Starlinks. Starship's purpose is to launch satellite constellations for other companies. You can imagine Amazon is going to launch Kuiper on Starships. And it's going to make so much money doing this. So, I personally thinking about Starship as a Mars, building a colony on Mars is a total distraction. It's almost never going to do that. But it is going to make a boatload of money launching satellites into low Earth orbit.
All right, so I'm going to explain how you can get access to all of the live streams, all of this content you've been enjoying over the summer. Here's how to get it all. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Barry Lake Roofing, Bill, David Giltonen, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, SpiderSwap.io, Paul Robach, Stephen Krasaki, Stephen Filer Munley, and Vlad Shiplin, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So we do the live streams every Monday, and if you don't get a chance to attend them live, but you still want to watch them after the fact, we make that link publicly available for free. But you have to go somewhere to get it, which is you have to go to our Patreon. Now you can follow us on Patreon for free. There's no expense every month. All you have to do is go to patreon.com/universetoday and then click on follow, and then you will be subscribed to our content. And every publicly available video that we release, you'll get access to that. When we release the question shows every week, we put a link to the full unedited live stream. And so when you get that email, you just click that link and then you can watch the live stream from last week. So if you feel like you're missing out on content, like an extra hour every week, that's how you get it. All right, well, we will see you next week with the first episode of the regular question show now that we're off our hiatus. All right, we'll see you next week.